Have you at any point dissected whether we're genuinely alone in the universe, or if there's something more to our world than what we witness? Imagine what would happen if the James Webb Telescope finally showed that we live inside a black hole. It could change everything as we learn more about this groundbreaking discovery. One that will make you question all that you assumed you knew about the universe. So, what exactly are black holes? They're like something out of a nightmare. Sure, you might have seen them in sci-fi movies, but in reality they are truly terrifying. According to experts, black holes in space are believed to contain massive amounts of matter compressed into an incredibly small region. Imagine a star, typically much larger than the Sun, squeezed into a sphere the size of New York City. The gravitational pull is so strong that nothing, not even light, can escape from it. Scientists have been fascinated by black holes for a long time. They have studied objects in space that are so massive and dense that they can trap light. The most remarkable theories about black holes were predicted by Einstein's theory of general relativity. Essentially, when a massive star collapses, it leaves behind a dense core. If the mass of this core is several times that of the Sun, gravity overwhelms everything, leading to the formation of a black hole. Detecting black holes is no easy task since they do not emit light. However, scientists have found ways to infer their presence by observing their effects on nearby matter. For example, if a black hole passes through a cloud of interstellar matter, it will pull that matter toward it in a process called accretion. Additionally, when a normal star gets too close to a black hole, it can be torn apart, emitting X-rays in the process. Black holes also have a significant impact on their surroundings. They can consume nearby stars, emit powerful radiation, and even influence the formation of new stars in some regions while slowing it down in others. But where do black holes come from? Imagine stars, once massive and powerful, meeting their violent end in a spectacular event known as a supernova. From the remnants of these fallen giants, black holes emerge. Most black holes are born from massive stars that have reached the end of their life cycle in a supernova explosion. Smaller stars, when they die, become what we call neutron stars, extremely dense but not dense enough to trap light. However, if a star is several times the mass of our Sun, it collapses under its own gravitational force, forming a black hole. As these collapses occur, something strange happens near their surfaces. Time itself begins to behave differently. From the perspective of a distant observer, time appears to slow down near the event horizon, the boundary beyond which nothing can escape. It's as if the star's clock ticks at a different speed compared to our own. Sometimes, when two smaller black holes collide, they merge to form an even larger and more terrifying black hole. If a black hole interacts with a neutron star, they create a colossal cosmic phenomenon that defies comprehension. Scientists have been studying these massive objects for decades, trying to unravel their mysteries. Black holes come in two general sizes: large and small. However, small is relative when it comes to black holes. The remnants of giant stars can be 10 to 100 times the size of the Sun, and there could be as many as 10 million to a billion of them in the Milky Way alone. That's an astonishing number of black holes capable of swallowing anything in their path. But wait, there's something even more epic. Supermassive black holes exist at the extreme end of the spectrum, millions, if not billions, of times larger than the Sun. They reside at the centers of massive galaxies, including our own Milky Way. They act like gigantic voids, pulling everything toward them. Renowned physicist Stephen Hawking spent his life studying black holes. His discussions were always captivating, though some of his theories remained unconfirmed due to a lack of necessary equipment. But now there is hope. A single scientific instrument is making a massive impact, and we're not ready for it. It's called the James Webb Space Telescope, JWST, and it's here to explore the depths of our universe. The JWST is no ordinary telescope. It's an engineering marvel and a testament to human ingenuity. Sure, we've launched other space telescopes before, and they've done their jobs well, but this powerhouse is truly extraordinary. The JWST makes the Hubble Space Telescope, which has served us for decades, seem like a mere speck in the vast universe. And the price tag for this astronomical wonder? A staggering $10 billion. Yes, you heard that right, that's enough zeros to make your head spin. Bringing this marvel to life took the combined efforts of NASA, the European Space Agency, and the Canadian Space Agency, along with contributions from over 300 universities. However, such an ambitious project comes with its risks. This is not a mission for the faint-hearted. The JWST is venturing into uncharted territory, pushing the boundaries of what we know and taking us to places we've only dreamed of. After a successful launch, NASA recently announced that the telescope has enough fuel to last more than twice its initial mission lifespan. Since its launch, the JWST has achieved several extraordinary milestones. It traveled over 1 million miles to reach its orbit around the Sun, where it will remain permanently. During its journey, the telescope successfully deployed its massive 5-layer sunshield and its giant primary mirror, both of which had to be folded to fit inside the launch vehicle. Now, after NASA has calibrated and adjusted it, the telescope is almost fully operational. One of the most captivating moments of the JWST's mission was when NASA announced that it had captured its first images of starlight. The first image taken by the telescope was of a star called HD 8446, resulting in a mosaic of 18 scattered bright spots, each one representing the reflection from the 18 mirror segments on the primary mirror. NASA later released another breathtaking image of HD 8446, in which the 18 unfocused copies of the star were aligned into a precise hexagonal arrangement. Changes in the singular sections of the essential mirror. It will start the process of stacking images, blending 18 pictures into one clear view. Thanks to its state-of-the-art innovation, the JWST will assist specialists in studying the early stages of the universe after the Big Bang. It will focus on what happened after the first stars formed, in a period known as the epoch of reionization. This refers to when neutral hydrogen was reionized, given an electric charge again, by radiation from these first stars. This includes looking back billions of years, which is only possible with a powerful telescope like the JWST. The telescope will also support the discovery of exoplanets, which are extremely difficult to detect due to their interactions with their host stars. Its powerful sensors will be able to observe these planets in greater detail, sometimes even imaging their atmospheres. Understanding the conditions of these planets could help scientists predict whether certain planets are habitable. Studying the evolution of planets and galaxies. Beyond exoplanets, researchers are studying galaxies to understand how matter is organized on a large scale. This, in turn, helps us recognize how the universe evolved and how the twisting, curved galaxies we see today formed from various shapes over billions of years. One of JWST's main objectives is to look back at the earliest galaxies to better understand their development. Scientists also aim to understand how we got the range of galaxies we see today and how they continue to form and evolve. The biggest questions of all. But most importantly, the James Webb Space Telescope will help us answer some of the biggest questions. Are we alone in the universe? Are we living inside a black hole? JWST has already begun its search, and guess what it found? Compounds called polycyclic aromatic hydrocarbons, PAHs, hiding around massive black holes in 3 active galaxies. These carbon-based molecules with ring-like structures are the goth children of the universe. They're everywhere, from distant galaxies to comets in our own solar system. They are fascinating not just because they could be the building blocks of life but also because they help astronomers track star formation. When ultraviolet radiation hits these PAHs, they glow and emit infrared light, a signal that JWST's mid-infrared instrument, MIRI, can detect. This is usually a sign of warm, young stars nearby. A shocking discovery near black holes. But wait for the twist. Curious astrophysicist Ismael Garcia Bernard from Oxford University studied 3 active galaxies, NGC 6552, NGC 731, and the famous Stephan's Quintet, located millions of light-years away in the depths of space. What he discovered will send chills down your spine. In the central regions where black holes dominate, he found an abundance of PAHs. Sounds interesting, right? Well, here's where it gets eerie. The radiation near these colossal black holes altered the PAHs, essentially transforming them into larger, electrically neutral versions of themselves. The smaller, electrically charged PAHs vanished into the darkness, almost as if they were consumed by it. Are we living inside a black hole? But there's a bigger question at play. Do we even exist? Could everything around us exist because we are inside a black hole? Could our entire universe, the galaxies, stars, and everything we've observed for centuries, be trapped within the pull of a black hole? JWST might finally provide the evidence we've been waiting for, opening the door to a new understanding of our very existence. If we are truly inside a black hole, it would change everything we think we know. The observations we make could be distorted by this very fact. Imagine this. Black holes are often seen as cosmic vacuum cleaners, pulling in matter, light, and even time itself. But what if our entire universe exists inside one? Could JWST's findings eventually reveal a larger, more complex structure, a multiverse, suggesting that our universe is just one tiny bubble within a grander cosmic landscape? The future of space exploration. These are the kinds of questions humanity may soon be forced to answer, thanks to JWST's groundbreaking technology. As JWST explores distant exoplanets and galaxies, it could confirm or challenge our current understanding of the fundamental laws of physics. We may learn how black holes influence their surroundings in ways we haven't yet grasped, opening new avenues of research into quantum mechanics and gravitational waves. By looking deeper into the universe than ever before, the telescope could even detect echoes of the Big Bang itself, providing clues about the origin of our universe and its possible fate. A new era of discovery. But JWST isn't just looking outward, it's also allowing us to look inward at our own place in the universe. The search for habitable planets will take on new urgency as the telescope's instruments enable scientists to analyze exoplanet atmospheres with unprecedented detail. Are there signs of life beyond Earth? The discovery of biosignatures, or even the building blocks of life, on distant worlds would be a game changer, offering the most undeniable evidence yet that we are not alone. And if JWST's findings validate the theory that we are inside a black hole, it would force us to rethink our understanding of existence itself. The laws of physics as we know them might no longer apply, or they could operate in ways we can't yet comprehend. If our universe is truly inside a black hole, could there be other universes within other black holes, each with its own unique laws of physics? The idea of a multiverse would no longer be just theoretical, it could be a natural consequence of black hole physics. The journey has just begun. As JWST continues to explore the farthest reaches of space, the answers it provides may raise more questions than they solve. The mystery of black holes, the origins of the universe, the search for life beyond Earth, and the very nature of existence are all on the table. With each new discovery, humanity stands at the threshold of a new era of scientific exploration, one that promises to push the limits of human knowledge. In the coming years, as JWST's data pours in, we may witness some of the most profound discoveries in the history of science. Whether we are living inside a black hole or on the verge of the most incredible revelation of all time, one thing is certain. We are on the cusp of a new understanding of our place in the universe. And perhaps, at long last, we will find the answer to whether we are truly alone, or just a small part of a much greater cosmic structure, waiting to be uncovered.